Exotic, gotta flex.
Welcome, everyone, to another session of the Logos Dev Club. Thank you for being with us. I am Chair. I'm the program manager for Waku. With me today are SP, Waku research engineer, and Arseni, JS Waku team member.
Hello.
We will be picking up where we left off in the last Logos Dev Club session, you might remember, from this past Monday. Wherever you are watching, if it's X or YouTube or anywhere really, please like, retweet, share, subscribe, turn notifications on for Logos, as there is an abundance of things coming down the pipeline and towards you that you should be aware of if private peer-to-peer technology is something you are interested in. I do implore you, beyond the sharing, to visit logos.co. It is your central hub for whichever branch or direction you want to take down your journey of discovery. That is logos.co. There is a brand new website coming up, coming very soon. But for now, you can certainly still set your bookmarks for logos.co. And I'll move quickly as we have a lot to get to today. But another thing that I want to mention for this audience specifically is that there is the RealFi Hackathon is happening currently. There's about 8 days left for you to work on your submission and submit it for your chance to win a share of $8,000 split between 2 tracks sponsored by Logos. Go to realfi-hack.devspot.app. You can find all of the pertinent links at the Logos X account or logos.co. There is a keycard track. There is a Logos tooling track. There's plenty for you to choose from in terms of solutions that you want to build. There are a ton of suggestions that we have in terms of what might be useful for you to build that might get the attention of the panelists, as we are specifically looking for internal tooling that is needed for Logos immediately. So you can be sure that if your project wins, it will be used. It will be used immediately and maintained by Logos. So follow Logos, enter and register for the hackathon, begin building thusly, and reach out for any questions that you might have. So, to set the stage for what happened these past 2 streams of the Logos Dev Club SP you have been working on in Rust, I will mention, in Rust, private content topic sharing between nodes and how that might work. You really have been using Grok as your LLM of choice, and we have called into the bullpen the manager. Oh, this is a baseball reference, so I apologize, folks, but the manager has tapped his right arm to bring in the righty, and that righty is Arseni, who is an avid user of LLMs.
User and abuser.
Maybe we should lead with abuser.
Folks, these things are not conscious. Do with them what you will, as long as it's within the boundaries of the law of whatever jurisdiction you have in.
Yeah.
So now that we have a team of 2 approaching this problem, this solution that we are working towards, SP and Arseni, I hand control of the vehicle to you. And perhaps, SP, if you could lay out where we're at now, where we have come from, and perhaps where Arseni's LLM knowledge can be leveraged going forward.
Hey, I do have to. I kind of have to hop off in like 7 minutes, but
Mhm.
I think I already identified like something interesting. So,
Oh.
SP has been working on this quote unquote artisanally, not
Yeah, I mean, the idea was suggested by the so
yeah. So this is a great this is like a very this is like a pretty non-trivial problem. And so I think what we can show is like how does a very very basic usage of LLM of an LLM Claude Code specifically like assist an engineer, right off the bat. And so what I did is I took the code that you sent me, and it was just a single file. I put it in a repository, and I opened it with Claude, and I just said, hey, like make this work because there needs to be a cargo project or whatever. But even without the repository, made it work. Are you sharing my terminal?
I will share it right now. Arseni, your audio is a little bit
What
muffled.
about now?
Better.
Okay.
Whatever you just fixed is better. Okay, we can see your terminal.
Perfect. Okay, so what I did is I put it in there. At first, I opened Claude and I told it, make this work, make it compile, whatever. And then I said, I opened it again and I told it, what is this? Like, just to go through the code and tell me what this is. So I'm very curious if what Claude has written here is actually like accurate and matches what you were trying to achieve. So the first thing it identified is that we're implementing elliptic curve Diffie-Hellman private set intersection.
yes, indeed, that is the cryptographic principle, I guess, that would allow us to do the private set intersection in the cryptographic technology. It's the yeah, that's as I understand it, that is right. Yes.
Yeah, and so part of what this I think like should tell you and like any developer who does something similar is like if you put in your code, if you put Claude code in the repository you're working on, you ask it, what is this? Like go through the code and tell me what it is. And if what it tells you like matches with the expectations of like what you're trying to achieve, it probably is a good sign, right? It probably means that you're on the right track, the code is somewhat readable, documented, etc. So we can I'll just let you glance at this. Does the how it works specifically, does this seem correct?
So okay, so there's 7 steps. Step 1, both parties generate random scalar. Yes, each hashes there to be input. Yeah, so step 2 would be maybe not clear from the code. We are assuming that those 32 bytes are actually the hashes of Waku content topics, but maybe from the code you can't understand that, but that's what we were going for.
So this is for 2 nodes to be able to identify that they're serving the same or supporting the same content topics without revealing all the content topics they support.
Exactly, yes.
Oh, that's awesome.
Yes, it is.
You're working on
if it works, it's going to be cool. So step 3, yes. So you take Alice and Bob. They both take their secret, and then they basically multiply their secret with the hashes of each content topic. And those are called blinded points. Then they exchange their blinded points. Step 4, that is correct. Step 5, they receive it, and they multiply their own secret with the blinded points of the other. So Alice is going to multiply all the blinded points of Bob with her own secret. So now you get double blinded points. And now you can do the intersection of those sets of double blinded points, which is step 7, I guess. Return intersection, blah, blah, blah. Yes, basically, yes. Step 7.
Folks,
so this is
community
correct.
of property. You thought it was useless, but here we are.
Yes, commutativity is because we're multiplying. So yeah, whatever. It's yes.
Cool. So that after while we were doing the intro, I then just told it try it. So that's another good like basic check. First is explain what it is, and then you tell it just to try it, and it'll do what it can to figure stuff out. So here it wasn't able to compile because it claims that the V4 API for curve 25519 Dalek has changed, and it edited my cargo toml, but it's very possible you had already had this set up in yours.
Yes, my version is 4. Yes.
It did some other changes, and then it claims that the test had passed. The fix was to preserve the hash to point mapping during the blinding exchange instead of relying on array indices, which don't maintain order with hash maps.
That kind of makes sense. Yes. Last episodes when we decided to start using Grok to build more code instead of me trying by hand, basically I was able to do the intersection of the double blinded points, but then you have to associate the topic hashes with the double blinded points to be able to know which topic associate with which double blinded points. So that association was not there. So I was trying to do that. I'm kind of a bit rusty in Rust, and I was having some problems. So we decided to just ask Grok to do it, and it kind of worked, except that the test failed. So it compiled, but the test failed. So I'm not sure what Claude thinks of this, but yeah, that was the space we left.
The test is passed. So I will quickly. I'll send you the code.
Okay.
And you can. You should review it for yourself because it is possible that it made it a pass by just breaking the test or making
by fiat. Yeah,
just making it not detect anything. But honestly, that was like really all I wanted to show is one, Claude Code is probably better than Grok at writing code.
Probably, yeah.
And two, just like even if you're not a quote unquote vibe coder, just using LLM to sort of get a bit of feedback. One, like can it accurately identify like what you're trying to do just by reading your code? And two, can it try it? Can it run it? Can it test it? And then sometimes it'll, especially when you're using Rust and the compiler gives you such good like information about your error, sometimes it'll be able to use that feedback immediately and apply a fix. Sometimes the fix is what you want. Sometimes the fix is not what you want. But I've sent you the code, so feel free to check it out, or even like proceed on your own and then see if like what you come up with matches what.
So I used your code. It compiles and the test passes. But now, does it actually test what we needed to test? That is the question.
Yes.
So if you have to go, I guess we could check that with just me and Chair. We're going to carry on.
Sounds good. Yeah.
Thank you for joining us, Arseni.
Thank
I really
you.
appreciate it. I know you have to run.
Yeah, I'll happy to hop on again. But yeah, good luck, fellas.
Thank you. Bye.
That was JS Waku engineer Arseni coming in with a bit of guidance. SP, what do you think now moving forward? Do you have a bit more?
Yeah, like I said, I guess we are going to review Claude's code and see what the differences are exactly. Maybe there was just a slight mistake that Grok made. I'm not sure exactly. So let's check again. It's commented, so it should be easy to follow. So step 1, generate scalar. That's easy, and you just random numbers. Step 2, map hashes to Ristretto points and store mappings. All right. So we have now a map of ashes to respective points. We start from Alice ashes, then we create the points from the ashes, and we keep the ashes as the key. So yeah, so that's basically the same thing we did before. But then step 3 is blind points. So we iterate on the mapping. We take Alice secret and we multiply with the points. We do the same thing with Bob. So this is the same thing as before. That's fine. Step 4 is only simulated. We should be exchanging that information over the wire. It's just a prototype. We're not going to do that. Step 5, we have to compute the double-blind points and keep the mapping to the ashes. So maybe this is the step where Claude is better. Okay, let's see. So it started with Bob ashes to blinded points. And then you take P, which is the point, you multiply it with Alice secret, you get double P, and then the tuple is now the ash, just like before, and the double blinded point compressed and mapped 2 bytes. So just the 32 bytes that represent the point. So this is now Alice double blinded points. And Bob is the same thing. Okay, so I think that was the same thing before. Let's see, step 6, compute intersection and map intersection asses to double-blinded points. Okay, so we start with Bob double-blinded points. I'm not sure what that is exactly. We iterate, but we don't do anything, which is weird. Wait. Yeah, I'm not sure why. There's no function here, so it doesn't do anything. All right, let's move on. I'm not sure why the AI wanted to do that. Maybe it needs a copy, and that's how it did a copy. I'm not sure. Let's see now. Alice intersection. So you declare a new vector, and then you declare a new ash map, which is called intersection to double blinded. Okay. Now you start enumerating Alice's double-blinded points. So you get the ash and the double-blinded point of the bytes of the double-blinded points. And then you do, I use the any function. So any test if any element of the iterator match a predicate. And so we compare Bob double bytes, basically the copy of the Bob double-blinded points, with the Alice double-blinded. So this is doing the intersection basically. So if we find a match, we add the ash to Alice intersection. So this is the content topic ash and not the double-blinded points. But we also add the double-blinded points to intersection to double-blinded. So it's ash, double bytes. So we do that. Okay. And then we do this. So that was Bob. Now we do the same with Alice. We kind of, in a weird way, copy the double-blinded points. Okay. Then we do the same intersection. So we check all the double-blinded points of Bob. and we check if any of them intersect with Alice double blinded points. If they do, we push to Bob intersection. And then it says update mapping if not already present should match Alice's. Yes, that is correct because we do the same thing here. So it uses entry, which is gets the given key corresponding entry in the map for in-place manipulation. Ah, I see. Okay, and then it use or insert. So if it's not already present, it inserts it. Okay, so I guess that's the problem. By doing this, if one of either Bob and Alice has a double blinded point that corresponds to a Ash, it's going to end up in this intersection to double blinded. Okay. So, but let me think. Is it actually a problem? Is it a problem? Maybe not. It should be symmetrical, so if you insert it here or first, it doesn't matter. Yeah, I guess it doesn't matter. So it says update mapping if not already present. But I guess it should be already present because you would find all the intersection already by doing just this. But I guess the point of doing this is so it's to simulate having two parties in the protocol doing the same thing on their own side. So yeah, okay. I'm thinking it makes sense. Probably. Okay, let's move on to step 7, verify intersection match. So this is where it was failing last time. So basically we take the Alice intersection, we create a set with that. Alice intersection is where we pushed the content topic ashes. The same thing with Bob, and then we compare the two. So these should be equal. Last time it failed, not sure why, but now it works. And then step 8, it's to verify that the intersection and the ashes correspond to actually the double blind points. So we iterating on Alice intersection. So those are ashes. We assert that the intersection to double blinded map contains a key, which is the map. It contains a key, which is the ash. Sorry. And wait, this is what's the type? So it's an ash map of I get yeah, we should have used maybe an alias for the ashes. That would have been simpler and more readable, but so when you insert the key is the ash. Yes, okay, just to make sure.
Speaking of readable, folks, your comments in the chat are readable, and your questions, most importantly, if you have any, please insert them on X or YouTube, wherever you are watching, and please like, share, and subscribe. SP.
Yes. So this assertion is making sure that a topic ash in Alice intersection is present in the intersection of the double blind points. If it's not, it's going to return this message, intersection hash missing in double-blinded mapping. That makes sense. Now it's doing something else. Intersection to double-blinded hash. Okay, so it's taking the value associated with the hash, then it asserts that Alice double-blinded points that somewhere in there is actually the same double-blinded points. And it does the same with Bob double-blinded points. So somewhere in there, it's part of it. If it's not, it returns this message: double-blinded point for hash does not match both parties, because we're doing an intersection. So both Bob and Alice should have the same set of double-blinded points, which correspond to the intersection. All right. So that makes sense. And then it returns Alice intersection, Bob intersection, and the mapping. And then when we run or when we check the actual test, we create 90 random topic hashes. Those are different in Alice and Bob sets. Then we create 10 same topic hashes that we insert in Alice and Bob sets. Then we call the function that we reviewed. Parameters are Alice set, Bob set, or vector in this case. Then it returns the intersection, like I said before. So the actual asserts are here instead of in the actual test, which is a bit weird, but yeah, it works. Basically, I've come to the conclusion that it works, Chair. It works.
Exclaim. I always knew it would.
We still don't know what Grok missed, but Claude worked. It found the error, so I'm guessing that's great. That yeah, are we done here, or
is there anything otherwise that you need to validate or
we
run?
could make the test a bit more difficult?
If you wanna up the test case slightly, and
because
not
if you
create more work.
noticed the actual intersection, the random topic hashes that are the same in Alice and Bob's set or at the same index. So we could say, well, we want to randomize that, right? We could want to randomize it so that we know for sure that it's not just a fluke of keeping the same order. It's not order based. The AI already because if the AI picks up on the test, it could fake the test. Not in this case. We just reviewed the code. But if I'm guessing if you use AI, it could pick up on the test parameters, and in this case, it could just check the indexes and the ordering of the random topic hashes instead of having to do the actual set intersection. So that would be a enhancement to the test. There's also this to do. Check that nothing else is revealed. Because if you remember, we're doing private set intersection. Mm-hmm. So it's good that we get the intersection, but if by doing so we reveal more than the intersection, that is not good. So I guess we could start with this. It should be relatively easy.
Oh, you heard it, folks. It should be easy.
Yeah,
Just like it's easy for you to like, share, and retweet this stream right now.
those are famous last words. It should be easy, and then you fail.
Good luck, XP.
But I'm thinking in this case we could just check the intersection size, right? Um, so if the size is the same, then we can be pretty sure that yeah, nothing else than the actual intersection is revealed. Um, but the asserts in the code here, they kind of check every ashes, so it's kind of implied already that it doesn't reveal more, but just to be sure. So we're gonna just assert or assert equal, yes, assert equal that Alice intersection dot len is equal to Bob. Bob intersection dot len. And then we should also check that it's both Alice and Bob intersection are same size as the mapping. So maybe do this and this, and it would be Bob here. It's kind of redundant, but yeah, we could do that. And if we run the test, still gonna work. Hopefully,
Okay.
yes, okay. Phew, okay, yes, it works. So now we're almost 100% sure that it is actually a private set intersection.
That's beautiful.
Yes.
I guess my question at this point would be how immediately applicable is this to the Waku protocol?
That's interesting. That's a really good question. So, with this technology, we can have two Waku nodes, find the common set of content topic they are interested in without revealing the other content topic they are also interested in, just the common one. And then with that list of, or that set of common content topic, we can do, we could use Waku Sync to synchronize messages between the two nodes. That was mostly what I had in mind when I was brainstorming with the AI for this cryptography gadget. But maybe there's other use case. I'm not sure. What do you think? Would it be useful elsewhere? So knowing the interest of the common interest between two parties.
Intuitively, it feels like this is quite useful. In the limitations of my technical ability, make it difficult to see the path clearly of where it should be implemented and how exactly it should work. But thinking about what's coming down into next year with like Logos Core and the tooling that developers will have at their hands to sort of spin up Logos Core and pull in the libraries and packages that they need. So for instance, if they need storage, okay, they pull in codecs in whatever capacity they need. They need comms, they pull in Waku. They want it to be particularly private, they pull in the private set intersection content topic sharing package by whatever name it will go by. I submit chair, but
Private chair.
it's random. It's a random chair intersection. So I think in thinking about that sort of user story for developers in the future, I think it's quite exciting.
Let me give you more ideas about useful tool for developers. So Waku Sync is one of the newer protocol in the Waku family. It's right now it's mostly used to synchronize store nodes. So if you decide to enable the store protocol on your nodes, you can also use sync to basically synchronize the store with other nodes that also enable store. So it works, or let me take a step back. If you don't want relay, you can just use sync and store. So it gives you a different path to propagating the message without using RLN relay, which is the pub sub mechanism that Waku uses. So in my mind, maybe I'm biased because I developed part of the Waku Sync, but Waku Sync is a bit special because it's the only other protocol that can propagate messages, right? So, and it does it in a different way that could be used by developers when a pub sub system is not fit. It's just speculation, but I think it would work in different contexts. So with this cryptographic gadget of doing the private set intersection, you could use Waku Sync to propagate your message without revealing all the topic interest of your nodes, right? So it augments or gives more privacy to the message propagation of Waku Sync.
So you can have a lighter weight node running, still maintains the privacy of the content topics it's interested in to some degree. So like an edge node even can obfuscate what it's looking for or what it's interested in. Very, very interesting. We do have a few chats coming in. Hello, Abdul. It's good to see you in the chat. Folks, this has been the third installment of the Logos Dev Club. Thank you, SP, for being here for all three. We have been on a very interesting journey if you've been following along for all three parts. You have reached a very satisfying conclusion along with us. So that's it's always nice to end on a success. We will be holding these Logos Dev Club streams often. So please subscribe and turn notifications on if you want to catch things live as they happen. There's all sorts of more content coming to you very soon. So it's all very exciting, and there's a lot going on. The Parallel Societies event was announced yesterday on the Logos Twitter space, which happens every Tuesday and Thursday from the Logos account on X. And I am vamping now as I'm looking for a very specific, there it is, for a very specific tab. And that is the logos.co tab, which you should go to now and bookmark because there are all sorts of things that will be getting updates in short order. In 2026, as far away as that might seem, is going to be very exciting. So go to logos.co. There are many branches and streams to follow from there. So choose your own adventure. Say hello on the forums. Join the Discord if you are so inspired to. We do have the Real Fi Hackathon in partnership with Tor, I might add. And speaking of more news coming, the Real Fi Hackathon is currently live. There are $8,000 in bounties sponsored by Logos across 2 different tracks, the Logos and Tor co-sponsored privacy infrastructure track and the resilient activist technology track. Winners receive cashish and key cards. And more about key card coming soon as well. My point is, if you're following the thread, is that there is a lot happening already. There has been a lot happening since as far back. Well, the Bitcoin white paper was released in Halloween of 2008. We're coming up towards that anniversary. And then Ethereum white paper was released in 2013 or 2014. And then, of course, Status had its ICO in 2017, out of which sprang VAC and Waku and Nimbus and Keycard and Codex and Nomos and so much more. And there is a lot to be revealed as things have developed. The sauce is simmering. It's almost ready to serve. So follow Logos wherever, whenever. Join the community. If things like privacy and liberty and preserving those for humanity are interesting to you, then you might find Logos interesting. We will be back here again soon. Again, SP, thank you. I look forward to the next round of vibing. And for all those that will be watching the recorded version of this stream, I do implore you to join the community as well. And thank you for sticking around as long as you have. This has been the Logos Dev Club. I am Chair. That's SP over there. And we will see you very, very soon. Goodbye and